As the sun sets, the night sky is teeming with countless stars that we observed. For thousands of years, astronomers thought the Earth was in the center of the universe, and the groups of stars form constellations. And the optical instruments, for example a telescope, appears to observe distant objects that are too far away. And our advanced journey will begin to explore the extraordinary universe before we discover wonders and the distant worlds in these extremes, and the beginning of time that we find out to understand. Our journey begins in space, starts high above Earth. Its atmosphere is mostly oxygen and nitrogen. The surface is covered by water. It teems with life. It rotates every 24 hours, still orbits around the sun for 365 days. As we move beyond Earth, we encounter our celestial neighbor, the Moon. It orbits around the Earth just 250,000 miles. Where 12 astronauts walked on this gray barren world. On its surface, there is no atmosphere, no weather. Only its surface is pockmarked by craters, hammered and bombarded by incoming asteroids. Dark regions on the Moon is caused by lava solidified from massive collisions. It always creates eclipses, and its gravitational pull keeps the Earth stable enough for regular tides. But the Earth sits in the perfect distance, in the zone where conditions are comfortable. As we move beyond Earth, we will take a journey in our solar system, where robotic probes explore every planet that helps scientists to understand. Get too close to the sun, we encounter the brightest planet is named after the goddess of love, Venus. It is often the sister planet because it's almost the size of Earth. Up close, it's wrapped in a thick layer of clouds, but those clouds are poisonous, made of mostly sulfuric acid, and the atmosphere is choked with carbon dioxide. And the greenhouse gases trap the sun's heat, making the surface temperature about over 800 degrees Fahrenheit, hot enough to melt metals like lead. And the pressure is 90 times greater than it is on Earth. And the surface is made of landscapes and volcanic activity and the lava. Conditions here are very inhospitable. Nothing can survive there. Approaching new close to the sun, temperatures become more hotter. The closest planet that we encounter is Mercury, about 36 million miles. This planet, with its huge metallic core, is a heavily cratered world, and temperatures at the day side is hotter than the oven, but at the night side, temperatures are very colder than liquid nitrogen. Until we approach about 93 million miles away in the heart of the solar system, the Sun. A yellow ordinary star is a hot ball of gas and plasma reaching 10,000 degrees. It's so enormous that you could fit 1,000,000 Earths inside, but the core in its interior reaches millions of degrees. Hot enough for hydrogen and helium to convert into energy that powers the star. And the solar flares and prominences expel deadly radiation and solar winds out into space. And we encounter a comet, an icy body that hurtles towards the sun. The heat bakes a frozen lump of rock, and the stream of charged particles from the solar wind blew away the gases, forming a tail that is visible from Earth. Until we travel beyond the Earth's orbit, until we encounter the red planet. It's named after the god of war, Mars. Its red color determines iron oxide and rust. Although smaller than Earth, it has a thin atmosphere. On its surface, conditions are cold and inhospitable, but its reddish terrain landscapes is made of vast, distinct features. A vast, deep canyon as wide as America is Valles Marineris, and dust storms cover the regions around the red planet, until we encounter the largest volcano in the solar system. It's 3 times taller than Mount Everest. It's Olympus Mons. And Mars was once covered by oceans of liquid water and supported the atmosphere, conditions for microbial life to flourish in the last billions of years, that scientists believe. Beyond Mars, we encounter a belt of countless asteroids. These millions of chunks of rock are the leftovers when the planets are formed. They range to the size of a pebble, others hundreds of miles in diameter. Beyond the asteroid belt, we encounter a realm of the outer giant planets. Around the 400 million miles, we encounter the king of the gas giants, Jupiter, the largest planet in our solar system, more massive than all of the other planets put together. With no solid surface, this planet is entirely made of gas. In its turbulent atmosphere, its distinct feature is an enormous storm, is the Great Red Spot. A huge hurricane bigger than Earth has raged for hundreds of years. The clouds in Jupiter's atmosphere are composed of hydrogen and helium. Its gravitational pull is so great, it catapults asteroids. Yet it's circled by diverse moons. Each of them have its distinct features. Among one of its moons, Io, is pockmarked by constantly erupting volcanoes spewing sulfur. And the moon Europa is covered in ice, with cracks and channels that can be traces of oceans of liquid water beneath its icy surface crust. Perhaps undersea organic alien life could possibly exist. And the biggest satellite, Ganymede, is larger than Mercury. Beyond Jupiter, we encounter another gas giant, is the jewel of the outer solar system, Saturn. Around 800 million miles, Saturn up close is easily identified by its rings. If we approach the rings are made of countless particles of frozen debris and ice. Some are microscopic, and others are bigger than houses. They appear the remains of a shattered moon, destroyed by the planet's massive gravitational pull. Further away from its rings, Saturn is circled by diverse moons. One of its moons is covered in a dense orange atmosphere, Titan. Approaching its surface beneath its nitrogen-dense clouds, liquid methane flows in oceans, lakes, or there could be organic molecules on this alien moon. What lies beyond Saturn? The sun becomes dim and temperatures drop to freezing. And we encounter the outermost two planets in 1 billion miles away. We encounter Uranus. Its tilted rotation must be 98 degrees, was a result of a planetary collision. We're in the solar system's outer reaches that we traveled so far. We encounter The outermost planet is Neptune. Its blue color determines methane gas. Its ferocious winds in its turbulent atmosphere is about 1,000 miles per hour. We encounter one of Neptune's big moons, Triton. On its surface, the icy geysers spew out jets of nitrogen gases. On the very edge of the solar system, we approach a belt teeming with millions of icy rocks and the frozen small worlds like Pluto and its moon in the cold regions of space. The sun, around 3 billion miles away, is becoming dim and appears as just another star. And we encounter the farthest space probe, Voyage 1, accelerating far into interstellar space. And beyond, we approach a cloud containing countless of frozen comets left over from the formation of the solar system. If space probes like Voyager 1 reach the nearest star, it would take thousands of years to get there. But at the speed of light, it would take a few years to get there as we travel into the stars. Beyond our solar system, we reach into interstellar space. Around 4 light years away, we encounter the nearest stars, Alpha Centauri. We're traveling faster than the speed of light. We measure in light years. We pass through countless stars. Distances are so vast, they're mind-boggling. Every individual star requires nuclear fusion that powers its interior, emitting more energy and light. As we encounter the constellation of Orion, we approach a nebula around 1,500 light years away. This stellar nursery is a massive cloud made of gas and dust. Inside the great cloud of gas and dust, new stars are born. Clumps of clouds are condensed. When the temperatures become so high, new stars begin to shine. And after stars were condensed in a great cloud, their powerful lifespans in millions and billions of years. And we approach the 7 sisters, the groups of 7 young stars. Around 7,000 light years, we encounter another stellar nursery, the Eagle Nebula, a vast cloud of these towers of dust and gas. In these pillars of creation, where stars are born within in these clouds of hydrogen. And some other stars have their own planetary systems. Worlds of rare forms of matter. However, if these exoplanets have the right conditions, alien life could possibly exist. we encounter a distant solar system. It's Gliesa 581. Within the constellation of Pegasus, around 50 light years away, some of these planets, perhaps a gas giant, orbits too close to its parent star. Its atmosphere is boiled and escaped into space by the solar wind. If stars are small, some are average, yellow like the sun. Others are small, red, cooler than the sun. But stars in their lifespans don't last longer. Small stars are average like the sun. The fuel that powers the star is used up. They become into red giants. And once the interior is manufacturing more heavier elements, they become unstable, expelling their gases, drifting into deep space, forming a planetary nebula. And in the center of the planetary nebula, the core remains of a star is now a white dwarf. And we encounter the Ring Nebula around 2,283 light years away. When stars are more massive than the sun, they become into red supergiants. Its fuel that powers the star is used up, burning heavier elements in its interior. When the cores collapse, the star becomes unstable until it explodes violently, a supernova. The enormous explosion scattered away gas and dust and the elements into space. In the heart of the supernova is the remains of a collapsed nuclei, a super-dense pulsar. It's around 12 miles across. It spins rapidly, that blinks from the distance. The Crab Nebula is a supernova remnant. It's around 6,000 light years. And the objects are far more denser than a pulsar, a black hole. And that neighboring star is distorted out of shape into the heart of darkness. The remains of a collapsed core of a massive star. The region of space-time is where the gravitational pull is so strong, not even light can escape. If we accelerate much farther, beyond the groups of countless stars, is the enormous spiral galaxy, containing hundreds of billions of stars. called the Milky Way. A spiral galaxy is around 100,000 light years across. And our solar system is located in the corner of its spiral arms. And the globular clusters that surrounds the galaxy contain thousands or millions of stars. And out beyond the Milky Way, around 2 million light years, is another spiral galaxy, Andromeda. Andromeda in the Milky Way, with surrounding smaller galaxies, make up a small cluster called the local group. And beyond the local group are clusters of galaxies are spiral, elliptical, and irregular. If we go unbelievably far, there are clusters and superclusters of billions of galaxies. Each individual white dot contain countless stars, and there are more stars than the grains of sand on Earth. Other galaxies, billions of light years away, could be the brightest, called quasars. They can be observed in most powerful telescopes. And the galaxies are separated apart is because the universe is still expanding. And we approach the outer limits of the universe. This is the universe. It's unimaginably big. Finally, we return back home, that we begin our journey. Complex cities, like San Francisco, are made of thousands of people and hundreds of buildings. But let's imagine if we enter the scale of the very small, to the atomic level. To understand how small that we reach, we have to enter the cellular level. Inside the human body, the magnification of 1,000 times. The human body contains billions of cells, and countless more. Blood cells circulate around the body that carries oxygen, is pumped by the heart. And the white blood cells fight against disease. In the tissue, we will approach the interior of the cell. Inside every cell, tiny molecular machines are manufacturing proteins. Starts within the nucleus. The nucleus contains long strands of a blueprint, DNA. A long twisted ladder molecule contains the instructions for organic life and reproduction. And the molecules in the DNA are made of smaller parts called atoms. Within the carbon atom contains swarms of negatively charged particles, the electrons. And we approach the atomic nucleus. Consists of protons and neutrons that make up the atom's mass. Every atom is a fundamental building blocks of matter. Perhaps they're composed with elementary particles called quarks. So next time, our journey continues before we witness the beginning of time to the present.